Okay, Assalamualaikum and hello everyone. How are you? Okay, so we're going to try finish off chapter 4, chemical bonding. So we're gonna start with 4.4, intermolecular forces. Okay, alright, so let's look at what we are going to learn today, our learning objectives. So today we're going to learn how to describe intermolecular forces. So you have van der Waals forces, dipole-dipole interactions or permanent dipole, London forces or dispersion forces, and hydrogen bonding. So, and then you will learn how to explain factors that influence van der Waals forces and hydrogen bonding. And finally, relate the effects of hydrogen bonding on the physical properties. Okay, the effects of hydrogen bonding on boiling point, solubility, density of water compared to ice. So, is water or ice denser? Okay. Alright. So, firstly, last time we learned covalent bonds, right? So covalent bonds, it is a type of intramolecular forces. So intra means intramolecular force means force within a molecule, okay? Inside, dalam molecule. Right, so today we're going to learn intermolecular forces. So what is intermolecular forces? Let's see. So intermolecular forces are attractive forces between your molecules. So intra is within your molecule, dalam satu molecule. Inter is, let's say, between molecule A and molecule A. So this is intermolecular forces. And intermolecular forces, they are much weaker than covalent or ionic bonds. They are about 15% weaker. Okay, how do we explain how they affect these properties? Kap cagi whale, saya salah cakap. So, if you look here, this one here in HCl, within the HCl molecule, this is the covalent bond. Your atoms are sharing electrons between themselves within this molecule. So intermolecular force is between two molecules or more, okay? Between molecules. So here you have an intermolecular attraction, a weak one. So this intermolecular force is weaker than intramolecular force, say covalent bond, okay? Alright, so how does IMF affect your physical properties of your molecules? So the physical properties like boiling point, melting point, and solubility, also density of water compared to ice. So these physical properties will depend on the intermolecular forces, alright? So the forces between your molecules are responsible towards these physical properties, okay? Right. So here is a chart, okay, of classification. So we have intermolecular forces, right? And under intermolecular forces, you have the first one, van der Waals forces. Okay. And another one is hydrogen bonding. Okay. Under van der Waals forces, you have two types of interactions. You have the dipole-dipole interaction and you have the London dispersion forces. Okay. We are first going to look at van der Waals forces. Van der Waals ni nama saintis ya. London pun nama saintis. Okay, so let's look at our first one, van der Waals forces. What is van der Waals forces? So, van der Waals forces is the forces that act between covalent molecules. Okay, So it is between covalent molecules. So you can have two types of covalent molecules, that is polar and non-polar molecules, right? So the two types of van der Waals forces you have is first the dipole-dipole forces or permanent dipole forces. So this dipole-dipole force is the intermolecular attraction between oppositely charged poles of nearby polar molecules. So note that it is between polar molecules. Polar molecules will have dipole-dipole forces. The next one, you have London dispersion forces. Dispersion, dia macam tu tak, disperse macam infection, faham tak, contagious gitu. So it is the intermolecular attraction between molecules as a result of instantaneous polarization of their electron clouds. Note here, instantaneous polarization maksudnya kapcagi polarize, tiba-tiba je polarize at a particular instant. At a particular instant, suddenly, okay? Suddenly, instantly. Let's say at time X. Suddenly it becomes polarized. It is non-polar. From non-polar, suddenly it becomes polar. Okay? We'll see how what it means later. So, first, dipole-dipole interaction under van der Waals forces. It exists between neutral polar covalent molecules. So, polar molecules only will have dipole-dipole interaction. Okay. Right here, ingat tak? Pernah nampak kan delta plus, delta minus ni? It means partially positive and partially negative n. Because why? You have unequal distribution of electron density within that molecule. So, your polar molecules, they will have permanent dipole due to the uneven electron distributions. So that means this HCl, this dipole here, this dipole, yang ni kan, ingat tak bond dipole? Ingat tak? Bond dipole ni, it is permanent. Okay? It won't suddenly disappear. So, the electrostatic forces between the permanent, partially positive pole of a molecule and permanent, partially negative pole of the neighboring molecule will produce dipole-dipole forces. Okay? This right here, this interaction, this attraction between these two ends, it is called the dipole-dipole force. Okay? Or permanent dipole. Was it? Apa? Permanent dipole force. Okay? So, it is between polar molecules, because polar molecules ada partially positive and partially negative. Therefore, between the molecules, there will be an attraction called dipole-dipole forces. Alright? Boleh? Okay. So, the strength of your dipole-dipole force depends on the size of the dipole moment. Okay. So, the higher the dipole moment, the more polar the molecule, and the greater the strength of the dipole-dipole attraction. For example, between HCl and HBr here. So, if you draw the bond dipole, the arrow, HCl is more polar than HBr. That means, if I draw the arrow, my arrow will be longer, reflecting the magnitude of my dipole banding dengan HBr here, pendek sikit. Okay? Therefore, the dipole-dipole forces in HCl are stronger than in HBr. So, this one, HCl, the more polar compound, a molecule will have stronger dipole-dipole force, okay? Okay. So, polar molecules ni, not only does it have dipole-dipole forces, but it also has London dispersion forces, okay? Dia ada London dispersion forces juga. Alright. So, polar molecule will have two intermolecular forces, which are dipole-dipole forces and London dispersion force. Okay. On your left here is the orientation of polar molecules in a solid. So basically, your polar molecules, kan, it has permanent dipole, right? Therefore, the molecules will align themselves so that the partially positive and partially negative charges attract each other. Okay, so there's dipole-dipole forces between your molecules. Alright, right here. Okay, boleh eh? Alright. So next, we're going to look at London forces or dispersion forces or London dispersion forces. So, LDF gitu, it exists in all atoms and molecules. So that means polar molecule has London forces and even non-polar molecules will have them. So even between non-polar molecules. Okay? How does that happen? It is a result from the temporary, bukan permanent macam tadi, instantaneous Kapcagi-Weyl polarization of molecules. Okay? Dia tiba-tiba je polarize. So the temporary dipole molecules will be attracted to each other. Okay, attraction. And these attractions is known, macam grammar dia, is known as the London forces or dispersion forces. Okay. So let's see the formation of London forces. I'm going to show you how Kapcagi-Weyl polarized tu. Dia tiba-tiba je berlaku, okay? So an atom has positively charged protons in its nucleus, right? And negatively charged electrons surrounding the nucleus. So usually the negative charge of the electrons ni, and negative ni, your electrons, is spread evenly, secara rata, around the nucleus. So this is a neutral atom. Okay? A neutral atom where the electrons are spread evenly. Okay. Tiba-tiba, at any instant, suddenly, okay, one side of the molecule has higher electron density than the other side. Okay? Dia tiba-tiba, instantly, the electron density distribution is unequal. So you have partial positive and partial negative N in your molecule. So at this instant, the atom or molecule becomes a small instantaneous dipole. Okay, so this molecule just now, yang sebelum ni dia neutral, evenly spread electrons, suddenly has dipole. So this is called, it becomes a small instantaneous dipole. Okay, dipole maksudnya apa? Dua polar kan? So maksudnya ada positif dengan negatif. So macam awak menguap dalam kelas kan? Awak tengok kawan nak menguap, lepas tu awak, it's contagious, tiba-tiba orang sebelah pun menguap, contoh. Atau tak apalah. Okay. Then this molecule induce a dipole on the neighbouring atom and molecule. Okay. Induce maksudnya dia infect, kononnya macam infect lah. Infect. Okay. a dipole. Tiba-tiba yang sebelah ni, okay, sekarang ni dia jauh sikit, dia belum lagi terkena jangkitan dipole tu. Lepas ni, awak tengok, it becomes a dipole. This molecule has dipole as well now. Okay. Due to electron repulsion, a temporary dipole on one atom, this atom can induce a similar dipole on a neighbouring atom, yang di sebelah, atom sebelah, which can cause the neighbouring atoms to be attracted to one another. So now, they are attracted to one another. Okay. Dia ada London dispersion force. So, this interaction is called the London dispersion forces, or just dispersion forces, and only significant when atoms are very close to one another. Alright? So, note, London dispersion forces happens to both non-polar and polar molecules. Okay? Right. So, this is just like a note for you to read. Okay, saya saja letak. This is another example. So, you can look at it for yourself. So, between this, from this neutral molecule, bromine molecule, suddenly, Kapchagi, dia ada temporary instantaneous dipole within the molecule. And then, it induced dipole to the neighbouring atom or molecule, this bromine pula. So this bromine has similar dipole like this bromine. So this one here, this interaction is called London forces. Okay. Alright. So let's see the examples, guys. So here you have HBr, SO2 and CH4 molecules. Okay, so how are we going to how are we going to find out the type of intermolecular forces within these molecules? I mean between these molecules, for these molecules. So let's start with HBr. First, you're going to see whether your molecule is polar or not. So you have to look at the polarity of your molecule. Okay. So HBr. Okay, before that. So kalau molecule awak polar, then it will have two types of intermolecular force yang under van der Waals forces. You have dipole-dipole forces dengan London dispersion force. Okay. Kalau non-polar, you will only have one type of intermolecular force, which is London dispersion force. London dispersion force is for everyone, gitu. Okay. So, HBr. Let's see. HBr is a polar molecule, right? Therefore, it has dipole forces. Betul? Betul tak? Senang je ni kan? And it will have dispersion forces. Okay? Between the HBr molecules. Okay. SO2 buat sendiri. CH4. CH4. You should know by now. CH4 dia punya polarity macam mana? You should know that CH4 is non-polar. If you don't know, then make sure to refresh molecular polarity, okay? So, it is a non-polar molecule. Therefore, it will have apa? Just one type of intermolecular force, which is dispersion forces atau London forces. Alright? Okay, boleh? Okay, senang kan? Okay, baru warm up ni. So next, we're going to look at the factors affecting the strength of the van der Waals forces. So, you will have 3. Molecular size, molecular shape, and polarity of molecules. Okay? These will influence the strength, kekuatan van der Waals forces awak. The strength of your van der Waals forces. Okay. So the first one is molecular size. So molecules with larger molecular size have stronger van der Waals forces as they tend to have more electrons involved in the London forces. Okay. So, key dia ialah more electrons. Kenapa kalau banyak elektron, London forces dia lebih kuat? Why is it that if you have more electrons, then your London forces will be stronger? It is because the movement of electrons, lebih banyak movement of electrons within your molecule, then the strength of your intermolecular force will be stronger. Okay? It's quite straightforward lah. Okay. So for example, if you have nitrogen molecule and chlorine molecule, if you look here, your molecular mass are different, right? So chlorine has a greater mass than nitrogen. Okay. And these two molecules, the similarity is that they are both non-polar molecules. Okay. So they have London dispersion forces. Okay. Both are non-polar, both have London dispersion force, but the molecular mass is different. Chlorine has greater mass than nitrogen. So when you look at the physical properties, the boiling point of chlorine molecule is much higher than of nitrogen molecule. Okay. This is because chlorine has larger molecular size and therefore it has more electrons than nitrogen. Therefore, the van der Waals forces, the London dispersion forces for chlorine molecule is much stronger than of nitrogen. Boleh? Simple kan? Okay. Now, next example. Here you have noble gases from helium to radon. Basically, this is down the group. Okay. So, when going down the group, the number of electrons increases. Therefore, atomic radius increases. Ingat tak? Ingat periodic table. Dah buat assignment kan? So, and then your boiling point from helium to radon, you can see that this is, ni paling sejuk. Okay? Paling sejuk, ni paling tak sejuk. So, the boiling point is increasing, going down the group. Maksudnya, you need more energy to remove pula. You need more energy to, the boiling point, you need more energy to reach boiling point for radon than helium. Okay. So, the distance over electrons going down the group increases. So, the distance over which electrons can move increases going down the group. Okay. So, size atomic size makin besar kan? So, makin banyak elektron kan? Lagi besar. So, dalam awak punya atom ni, it is much more distance for the electrons to move. So, therefore, the strength of dispersion forces increases going down the group from helium to radon. Hence, the magnitude of the van der Waals forces increases. Okay. magnitude maksudnya kekuatan dia lah. The magnitude of van der Waals forces increases. Therefore, more heat is needed to overcome these forces. That's why radon has the highest boiling point compared to the other noble gases. Okay, you need more heat because the van der Waals forces is very strong, much stronger in radon. Okay, boleh? So, next factor is the molecular shape. So, the molecule with larger surface area of contact have stronger van der Waals forces. Okay, what does it mean by larger surface area of contact? Maksudnya lebih banyak apa yang ada dalam bahasa Melayu? Surface area. Saya pun tak tahu. Okay. So, for example, here you have butane, okay, and you have 2-methyl propane. These two molecules, they have the same number of carbon and hydrogen. They are hydrocarbon molecules, okay, consists of hydrogen and carbon. They have the same molecular mass, but the boiling point is different. Okay, so 2-methyl propane has a smaller boiling point than butane. Okay, why is that? Kuning dah ni. Okay, so why is that? It is because of the molecular shape. You have a linear molecule and you have branch molecule. Okay. Here you have the skeletal structure of butane and 2-methyl propane. Okay, if you look here, butane here, it is a long and linear molecule. It has long and linear shape. Okay, so the long and linear molecules can develop bigger temporary dipoles. Okay, dipole tu due to large surface area which enables the movement of electron. So, butane here, it has larger surface area. Tengok. Nampak tak? Yang surface area of the exposed molecule, imagine lah, exposed atoms, it is larger. The surface area is larger. Compared to 2-methyl propane, dia not as exposed, if that makes sense. So the surface area is not as big as butane. Okay, so there is more movement of electron in butane, right? Although these two molecules contain the same number of electrons, kan? Sebab same number of carbon and hydrogen, jadi same number of electrons. So the long and linear molecules can also lie closer together. This allows greater contact between molecules. Okay, so diorang ni lebih rapat lah. They are much closer together banding dengan this branch molecule. Okay, nampak tak dia macam branch ni? So it's not as close as the long and linear molecule. So less contact. So this gives rise to greater London dispersion forces than molecules with more compact shapes. Okay, imagine ni kan, ni linear punya. So kalau linear dengan linear, dia punya contact banyak. Faham tak? Dia punya surface area expose pula. Surface area dia larger. Okay. Kalau the methyl propane, imagine dia macam ni kan. So, let's say lah, contoh when you put it like this kan, when you place them, when they are next to each other, when they are neighbours, the surface area in contact is not as much as the one above here. for between linear molecules. Okay. So macam ada yang kena, ada yang tak kena. Okay. So yang ni tak kena. Faham tak? Macam tu lah. So these attractions are at their most effective if the molecules are really close. Therefore, butane has a higher boiling point than 2-methylpropane. Okay. So remember, linear molecule versus branch molecule. Linear molecule will have stronger van der Waals forces, such as London dispersion forces, okay, than a branch molecule, right? So next we're going to look at the polarity of molecules. Okay. So for molecules that have similar molecular mass, nak dekat sama, the dipole-dipole interaction will be more dominant. That means you will be looking at the dipole-dipole interaction that will explain the physical properties. So polar molecules have higher boiling point due to the existence of stronger dipole-dipole interaction. Okay, digest benda tu. Okay, so if you look at this example here, this fluorine molecule and this hydrochloric acid molecule has similar molecular mass. Okay, cuba tutup yang polarity tu, kan? If you just look at this, the molecular mass, it is quite similar. But the boiling point is different. It's very much different. So HCl has higher boiling point than fluorine molecule. Okay, when they have similar molecular mass, these molecules, you will have to look at the polarity. Okay, because the polarity will tell you why, will explain to you why the boiling point is very much different than each other. So HCl is a polar molecule, while fluorine molecule is non-polar. Therefore, HCl, since it is polar, it has dipole-dipole interaction. So that dipole-dipole interaction is much stronger than London dispersion forces. Okay, so that's why the boiling point is much higher. You need more energy, more heat to reach the boiling point of your molecule. Okay. For example, why does this happen? What happens? Okay. You have trichloromethane, CHCl3, and you have tetrachloromethane, CCl4. Okay. Right here, you have the shape of your molecular shape of your molecules, and I've already put the bond dipoles, right? Okay. So tadi cakap if the molecular mass is almost similar, you will look at polarity, right? But in this case, this is a polar molecule and this is a non-polar molecule. So tadi kata the polar molecule will have dipole-dipole forces. Therefore, supposedly your boiling point will be higher for CHCl3. But right here, if you look at the boiling point, it is the same. Why is that? Saya salah? Adakah saya salah? Astaga. I want to punch myself, guys. Apa ni? Sabar sekejap korang. Astaghfirullahalazim. Saya tersalah awak. So yang ni 76.8 degrees Celsius. Sorry to waste your time. This will be mu equals to 0. So, why? Okay, sekarang it makes sense. So, just now we said that the polar molecule will have a higher boiling point than the non-polar molecule. Okay, but this doesn't happen in this case. Why? So, CCl4 has higher boiling point because it is a bigger molecule with more electrons. Okay, so the increase in the dispersion forces dominates the dipole-dipole interaction. So that means you are going to look at the number of electrons too, the molecular size and the number of electrons. Okay, so make sure look at this first. Okay, and then you look at the polarity. Okay, alright, boleh?